Why would I move? Not really.
Okay, cool.
Should be seen. Bless you. Bless you.
Okay. All right. I know you do. Hold on. I'm sharing screen, right? Yeah, cool. All right, here. I'm gonna hide me. All right, cool. Let's get going, guys. Here we go. So if you go to your notes on page 37, we did the one on the cookies, and we went through that, and we saw that the leftover dough was always the same. So let's talk about a more complex problem. This is the last problem we'll do. Then I want to give you guys some details about the test that you guys can jot down. And yeah, let's talk. Okay. So anyhow, so we're gonna wrap things up today. So tomorrow is just a full review day. So running track design is composed of two half circles connected by two straight line segments. Garrett is jogging on the inner lane with radius little r, while Devin's jogging on the outer with radius big R. Okay. If r little r equals 30 and capital R equals 33. Okay. So I'm guessing Garrett is going to be right here, and Devin's going to be right there. Does that make sense? So Garrett's running on the inside, and Devin's running on the outside, and the center is right here. This is page. This is the lecture notes, not the interview packets. It's all good. So clearly, Devin is running more, right? That's pretty obvious. And the question is, how much longer does Devin have to run to complete one lap for an exact solution? So how much longer? So we need the difference in distance. Does that make sense? I need to find their distances they run. Now, here's the deal. Let's start with Garrett. So for Garrett, and we'll get a little highlighter here. We'll use green for St. Patty's Day. You'd agree that's Garrett's path, right? Okay. So let's actually even that's really ugly what I just did. But those two are straight line distances, right? The one that now looks gray because I did pink over green. I guess it's gray. Um, so how long are each of those distances? 100, because it said so, right? So Garrett's gonna be 100 plus 100. So I strongly urge you for these kind of problems that involve like a lot of like mixed circles and rectangles and whatnot, be methodical. Be very, very methodical about this. So you have 100, right? For the straight line distances. Now let's look at the greens. The greens are semicircles, right? But together, the greens make this, right?
Wouldn't their circumference be? Oh, no.
So together, the two green half circles make a full circle. What's going to be the circumference of that circle? Yeah, because we know this is 30. So plus 2 pi times 30. So Garrett's going to be 200 plus 60 pi. So that's Garrett's path, right? Because he does a semicircle here. He does another semicircle. Well, two semicircles, doesn't that make a full circle? Right? Why you call semi in the first place, right? You got two of them. So that's Garrett. Now let's look at Devin. For Devin, does he still run the same straight line distances? Yeah. So 100 plus 100. That's fine. But now his circumference is different. So let's use a dark blue for him. Or I don't know what kind of shade of blue that is. But for that one, clearly we know that radius is 33. So plus 2 pi times 33. So clearly Devin does run a bit more. Garrett runs 200 plus 60 pi. Devin runs 200 plus 66 pi. So what's the difference between them? Perfect. Good. Excellent. But see, it becomes very clear when we're methodical, right? When we do this work, and by the way, if you made a little mistake, like, I don't know, somehow maybe you made a mistake here or whatever, I'm pretty generous with partial credit as long as you show me your work, right? But, if you do all the work correctly, then the answer should be pretty obvious. It's 6 pi. So it's 6 pi meters. Now, it did say to provide an exact solution, which I did do. That's exact. But to get the approximation, I'm going to need a calculator, right? So it's 6 times 3.14, which I think is 6, 8, 4, 18.8. Use a calculator, mind you. You get a calculator, by the way. Yep, please. Please don't use the calculator in your head. 6 by, 18.8 meters. Okay, hopefully that seems pretty straightforward. We're good with that? Okay. Okay, next up. Ooh, okay, what is the area contained between the two ends? Now that's a little tricky. Okay, so I'm going to replicate the track again down here. You don't have to replicate if you don't want to. Okay, so we want this.
You just like get the area and subtract.
Correct, right. But first off, keep in mind, you have these semicircles. It's think like this. Okay, so these can be a little crazy because you have. So first of all, I think it's pretty obvious what we need to find the area. Does that make sense? I'm trying to find the area between the two lanes, right? But I think where it gets complicated is how do you actually find those areas? How do you break these up in the recognizable shapes? So these two sections here, you guys see how these are both rectangles? The part that's not circular, right? How wide is this rectangle here? And how tall is it? What do you guys think? What's the height of this rectangle? The base is 100. How about the height? What do you guys think? What's the difference in the radius between the two lanes? So it's gonna be a 3 by 10.
Did you do like a subcatella thing to figure it out?
No, this doesn't involve right triangles. It's just looking at the diagram. So that's 103. Because if I go back to the diagram again, that right there, that has to be 3. Because 1 is 33 away, right? Because isn't that if you go backwards, I know this is getting really messy, but let me erase some of this stuff right now. I probably don't need all this here.
How do you know it's?
I'm gonna tell you right now. Just this eraser doesn't want to cooperate. Okay, this is how you can tell. How long is that? 30. Let's use a different color. How long is that? 33. So that little gap right there, what's the difference? 3, right? Do you guys see why it's 3 now? Yeah, so that's why height's 3. So you can have rectangle. The rectangles are 3 times 100 plus 3 times 100, which is 600. Those are the two rectangles. Then for the circular part, you got to do the big circle. So I think Maggie, you were saying this, or Reagan, you guys subtract the circles. You got to do the big circle minus the little circle. Well, how do I find the area of the big circle? You guys remember the formula? Actually, just look at circles. You don't have to use our sections. We're not doing sectors. Pi squared. And the formulas are in front of you guys. All the formulas, by the way, even the one for sectors and arc length, are all provided. You don't have to memorize any formulas. So 0 memorization for this test. Can't do 33 squared in my head. You're probably right. Yeah, good. 1089 pi minus 900 pi, which should be 189 pi. And so if we put it all together, $600 and that's how you get the exact answer. But remember, you have to do the big circle minus the little circle to get that shaded portion. It's like a donut, right? If you think about it, it's kind of like a donut. If I take this part, okay, let me switch colors here. If I take this part and this part, that forms a donut that we get over here. And so that's how I find out. So, and if they want the approximation, I'm 93.8 square meters. It's also written that way too, just so you know. Okay. So, questions? Yeah, I go.
Include the 600.
Because that's part of the area right here. Because what's happening is that this person. Let me
Aren't the two rectangles part of the bigger square?
Yeah,
Already?
bigger circle.
No, but what you're trying to find, well, here's what the question is asking. The question is asking, what does the area contain between the two lanes? So this is that's lane 1. That's lane 2. So you want the area between those two lanes. So you also have to include the rectangles also.
Yeah, but the rectangles are part of the bigger circle. So if you take the smaller circle, if you take the bigger circle and then just do or minus the area of that by the
Well, you could do this. I mean, if you wanted to, you could find this rectangle and that rectangle, take the difference. You could do that also. We still have to do that regardless. But why even do that if I could just find the rectangles directly? Because what you're doing is, this is the first area, right? That's area 1. That's area 2. What you're trying to do is you're trying to take this out. You want to get this out of the picture, and you want to find this. That's what you're trying to find. And these two are rectangles. That's why I had to find those rectangles first.
Okay.
I found those rectangles, and then I found the circular parts after that.
The circular parts that you found, wouldn't they include the rectangles if you're
No, they don't. No, because that's just this right here. Right? That didn't include this and this. Those are not included. So, but there's I think there's some practice problems like that in the unit review. Okay, so let's just wrap things up here. So just so you know, arc length, area, sector, you could just use ratios. If you know the central angle, divide by 360. That ratio is the same thing between the sector and the area of the circle, right? So we had delta math on that. So you can just use that ratio to help you out. Or you can make a formula, which is seen right there.
The arc and area sector on the test. We only have like a delta math about it.
I thought you asked the formulas. The formulas are provided. The last delta math homework was on that, homework number 21.
Yeah, but like is this like something that might show up on the test?
Maybe. Yeah. Actually, I'm going to talk about the test in a moment. We went through it right for Kanje. We figured that was a good time to do that. So yeah, I didn't teach it all Friday. It's crazy. And then arc length, same thing. Just find the central angle divided by 360. It's the arc length over the circumference. Or you can use a formula to express it. Same thing. Because you're multiplying both sides by 10 pi, right? So the arc length would then equal the circumference times the central angle over 360. So that's where that formula comes from. Just to kind of give you guys some additional practice to make sure we're comfortable with this stuff as well. And then I'm going to talk about just some general strategies, and then we'll talk about the test, and then you guys can review after that. Okay, this is a good practicing deal. I'll do the first row, then have you guys try rows 2 through 6. So, say for example, we asked this on the test. We said, "Hey, here's a table. Fill this out." Right? Not this elaborate because it's a little much here, but you guys should know these formulas. These formulas are provided, by the way. You don't have to memorize. These are provided. Do you guys remember how to find the what do all the angles what do all the extra angles add up to for a polygon? Do you guys remember? 360. It's in the formula sheet, right? Let me see the formula sheet again. Yeah. Yeah, it says it right there, 360. So that's obvious. 360, 360, 360, 360, 360. So easy peasy, right? Get it out of the way. Okay, the sum of all the interior angles. Do you guys remember that formula? Yep. Perfect. That's it. Actually, we divide by n later on. Yeah, we want the sum, correct. So n minus 2 times 180. Okay. Each exterior angle is going to be 360 over n. And each interior angle is n minus 2 times 180 over n. So we're just kind of priming this, right? Okay, we definitely need a calculator to go through the motions here. So again, I'll do the first row. Have you guys try rows 2 through 6. And of course, the last column's already been done. Okay, so 1440 is the sum of the interior angles. So therefore, 1440 equals n minus 2 times 180, right? Does that make sense? Right, because I'm just using the formula, right? How would I solve for n? What would I do? Algebraically, what do I need to do to solve for n? And then add 2. Yep. So I'll use my calculator. 1440 divided by 180, add 2, should be 10 sides. Okay, if that's true, then what's each exterior angle, guys? If you have 10 sides, 36. Good. See, now it's smooth. What's each interior angle? Boom. Got it. Okay. So you notice that this required a little bit of work, the sum of the interior angles. Now, sometimes you're given different things, right? But you should be able to figure this out pretty easily. Go and try rows 2 through 6. I'm going to do it also, and we'll check in a few minutes. All right. Here, I'll freeze the screen right now. Hundreds. And if there's a decimal, you can round to one decimal place. And remember, interior and exterior always add up to 180. Oh, what am I doing? All right. Ah, here we go. How are we doing? Okay. Sure. Yeah. 100%. All right. Here we go. Unit 3 tests.
What's your name? Yeah, let's get it out there.
Sure, that's fine. Okay. Let me unfreeze. That's what I'm getting. Let me know if you have questions. Second row is a little funky. Remember, the second, third columns have to add to 180, right? Interior exterior angles add to 180. You know this, right? You're simply dividing 360 by number of sides to get the measure of each exterior angle. Once you get each exterior angle, get each interior angle, and then the interior angles, you're just simply multiplying these together, right? Like, duh, just multiply together, right? One decimal place is fine. That's a standard, right? Yeah, 120 times 177, 30 times 168, and so forth. So you don't have to get so fancy with the formulas. You could just sort of just use logic. Like if I got 10 sides, each interior angle is 144, angle out to 1440, right? So of course use a calculator for some of the more complicated ones, like 30 times 168. But that's just kind of just a nice review of everything. Okay, so find area of a regular polygon. So questions on the table? We're okay with this? We're good? All right. For area of a regular polygon, just in general, what we want to do, figure out how many sides you got, draw the triangle, figure out the central angle, drop the altitude. By the way, I haven't used this term yet. And I'm going to talk about this when we go through the details of the test. The height is called the apothem. So I haven't talked about this. Let me do a little label with you guys here. So this right here is called the apothem. And that's kind of a funny term. Like, what the heck does that mean? That is the height of the triangle in the polygon, just so you know. We call it the apothem. We are actually going to test on terms. This is the only term I think you guys just haven't used that much. I think Mr. Davis has done it more than I have. But I'm just telling you right now, you got to be familiar with that term. So it's called the apothem. So if I ask for that, just that's what it is. That's all it is. The height of the triangle. That's all it is.
You ask for like the definition.
Correct. Correct. Right.
Give us like an example
Yeah, I am. Yeah, after I finish going over this, yeah, I will. Well, it's gonna be more matching, actually. I'll talk about it in a moment. Yeah, and so of course, how many sides you got? Like here, I got 6 sides, right? Cool. Draw a triangle. Cool. Drew a triangle. Figure out the central angle, 60 degrees, right? And then of course, if the sides, let's say the sides are 2 and 2, and that's 2, then that's √3, right? Once you do that, you could use trig or 36-90 ratios. That makes sense. Then calculate the area of the triangle. That's easy. 1/2 times 2 times √3. So it's √3. And then multiply by the number of triangles you got. So that's the process I just went through. So I would strongly suggest that you have this this flow chart, these list of steps with you as you're going through the practice problems when you go do the review, because this will just help you in figuring out how to get the area. There's actually a condensed formula. We haven't talked about that yet, but we want to make sure you guys are going through the motions of calculating the triangles first. Calculate the triangles, figure out the heights and the bases, all that stuff. You might do some trig if you need to, and then find the area of the triangle, then multiply by the number of triangles you got. So, okay. So I think that now officially concludes this super long unit. All right. So now let's talk about the test. And then I'll point you guys to some problems in the review that's helpful, and then you guys can practice. Okay, so here's what we're considering for the test. So test details. And this will be in Schoology because I'm recording this. So 50 minutes, standard time. Feel free to take notes, but I am recording this, so you can just go to the recording and just fast forward to that screen to take a screenshot. 50 minutes standard time. It's gonna be 50 points. So a point per minute, that makes sense. Formulas provided, all of them. Calculator allowed. Okay, that's kind of the basics. We're probably looking at about 8 or 9 questions.
The whole thing.
Whole test, yeah. Yeah.
But 80s.
Not exactly. Yeah, maybe yes and no. I mean, some yes and no.
So each question is gonna be like 6 points.
Roughly, yeah, or 4 points or something like that, or 5 points. It depends. Yeah, 100%. Yeah, this is actually very. Oh, no proofs. Okay. Well, then I'll give you all proofs then. Connor, fine.
Yeah, you should give us proofs.
Okay. What else can I say?
What about the like?
Here. Yeah. So here's what you should know. Yeah, matching terms with the diagram. So for example, if I gave you a diagram, you have to tell me, oh yeah, that's going to be the central angle, or that's an interior angle, that's an exterior angle, that's an apothem, that's the radius. Right. Like that'd be very basic, I think. Yeah, exactly. Match in terms of the diagram. So know your terms.
Like you'll give us the terms and we'll just
It'll be a diagram with a bunch of like things labeled, like this is like, side A, side B, angle C, angle D, and then there'll be a bunch of terms you have to say, oh, A is this, B is this, C is this, D is this.
The terms would be like interior angle, exterior angle.
Correct.
Oh.
Right. Yeah. So make sure you're comfortable with that. So know your terms. Trying to say
Um,
that's only one. Yeah, everything else you've heard of. Shaded area. Um, correct. Similar figures. I cannot write. Similar figures with scale factor. We've talked about that. And area. So similar figures with scale factor and area. Definitely want to know that. Area polygon. Angles of polygon. Um, circles. Area. Circumference. Arc length. Sector. That was like more recent stuff we've done. Yeah, I think those are the key ideas. I mean, we could ask like a couple of questions on the areas of polygon or a couple of questions on shade area, variety of circles, but those are like the main topics, I'd say. If you're looking at like a concept sheet, that would probably, I think, a pretty good one. Let me give you some good sample problems from the unit review, and then we are done. Then you guys can practice. Okay. And I'll try to see if I can create like some more practice, maybe a Delta Math, perhaps. I could try doing that. And I might try to also be available on Zoom Wednesday night. I gotta look at my schedule. I think I might be available. I'll let you guys know by tomorrow. Um, oh, late. It'll be after 9 o'clock. So it'll be a little late. Not exactly, but I could go to Delta Math to try to create something similar, perhaps. Let me see. Let me see what I can conjure up. Right now, you guys have plenty to do right now, but let me see what I can conjure up over the next 24 hours, and then by tomorrow, I'll share more stuff and have more materials I can find. But let me pull up the unit review. Okay. So the unit review, I mean, they're all good problems actually. uh, Anything in particular I might. Definitely. Actually, I'll do this.
you circle.
I'm just gonna put question numbers next to ones I feel are good. So, like, for example, for finding angles of a polygon, I really like number 37. You want to see how that looks? Definitely make sure you're very solid 37. 37 has several parts. You definitely want to be very comfortable with that. Number 37 on the review guide. For area of a polygon, I would say 38 would be a very good one to do.
Polygon needs to find the area of the shape.
Correct. Right. Yep. For similarity, I really recommend 46. That's a good one. I mean, just these are not the only questions you should look at. Ooh, really good. Shaded area, 58, 59, and 60. Those are outstanding questions.
We can
And actually, they do kind of follow. Oh yeah, go ahead.
6.
36. Take a look at 36.
Let's see.
We'll do that in a moment. Oh, hold on. Wait, what? Oh, I get it. Okay, I see what we have to do. Let's talk about that. Those are a little funky. Yeah, I mean, just trying to find. I mean, circles are kind of baked into the shade area, so that's kind of like where it fits in that category. Um, I think in terms of study notes, that's what I recommend for that. So yeah, those are some good problems to try. I mean, all these problems are good problems, but I think those are like some key problems that really, if you want to start with those, that'd be good. Okay, so for 36, let me help you out. Let me
Because like A and D were pretty easy to remember.
repack it. Perfect. Okay. Okay, so yes, you asked a good question, Maggie. Let me print that for you guys.
There's an answer key for pages 1 through 2, but I don't know if it's right.
Oh, let me see. Let me take a look. Actually, I'll print it while you guys are working because I have a separate pack I give you guys for the answer key. So for here's what I do, Maggie, for this one. I would actually draw the altitude. I do that.
Is that
Correct.
hypothem?
No, because we don't have a polygon. So that's 45. And that's going to be oh, hold on. Oh, you can't do this problem. Wait one sec. Yeah, you need more information. Yeah, you guys can't do this problem. You need more information. I would have to give another angle. Like, let's say if I told you this was like 40 degrees, then this would have to then be 50. Then this would have to be 57. Yeah, you can't do B, guys. You can't do it. You need more information. So don't worry about it. What was the other one you asked about, Maggie? See, okay. Okay, nonagon. How many sides? 9. Okay, good. So 360 divided by 9 gets you 40 degrees. That's each exterior angle, right? So how about the interior angle?
7 times.
Or just do 140, right? Because you have to the 180. Just make it easy for yourself. Okay, let's see here. Okay, so that's 140 right here, right?
20.
Correct. 20 and 20.
Other one is 120.
This is 120, correct. Let's see here. And that's 120.
You know that.
Oh no, so that's 140. My apologies. Because it's interior angle. Sorry, that's 140. What else? Oh yeah, that's 140. And that's 140. How do I know that? Okay, so I found the extra angles first. I did 360 divided by 9, which is 40. So the extra angles are like this. So that's 40 degrees, right? So each interior angle has to be 140. Because interior and exterior angles have to 180. Right? That helps tremendously if we do that. Now, do you see on the bottom I put 140 twice? So if you think about it, these are parallel. So what's X going to be? Remember we have parallel lines? 40, yep. Those have to have to 180, right?
How do you know they're parallel?
Because well, the fact that this is we would tell you that, by the way. We would tell you that. But you're connecting, it's a regular nonagon, right? So if you're connecting these two, I mean, these would have to, by default, they have to be parallel. Because it's a regular polygon. Also, the fact that these are the same. Okay, so that's 40.
Like you consider they're parallel, but then like how does that help you figure out that's
Because you have to have supplementary angles for same side interior angles. Remember from last semester when you have same side interior angles, they have to 180.
So that's
Right. Right.
It's like, that's like the transverse.
Correct. Yes. 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 That's exactly it. Therefore, this is 100. And that's 100. That's 80. And that's 80. So y is going to have to be 60 degrees.
We know it's 8.
And z is going to have to be 40 degrees. Oh, because yeah, this is where you guys. So now I see the disconnect. Now I understand why you guys are stuck. You guys remember this when you pair lines? What do A and B add up to? That's why you're not using that concept. That's why you're stuck. Because the interior angles out are 140. Let me back up a little bit here.
Isn't it like also?
Because x equals 40 and then the angle across from that is also 40. So
Let's say call us A. What would A and X add up to, guys?
40.
140, right? And X is 40. We already established that, right? Because of pair lines. Therefore, A has to be 100s. Oh, right here?
Yeah.
Because these are the same. And these are parallel. That's why. We would make that clear to you guys. I think we would state that just so you're not. We decide what we want to do, but it's not been finalized. I'll have a more final form by tomorrow before class. 140. Oh, but these have to have to 180. And that's A. So therefore Y is 60 and Z is 40. So you should get all those values for that. So yeah. Let me look at the test here. I have it in front of me, my other device. Sorry, I can't show it to you guys. I don't know if it's quite to that complexity. That's a little complex what we just did. But if you can handle that complexity, or if you can see that complexity, you'll be fine for the stuff in the test. Yeah. But yeah, you had to kind of tap into some other knowledge, right, to do that problem. So yeah. So anyhow, so yeah, just the rest of the class work. I'm gonna print the solution key for this so you guys have it. Let me see if I can find some other materials too that could help, and I might try to create Delta Math. So and then tomorrow is just more review. Just we come in, we just start reviewing. So yeah, so just work on the problems. I'll make it like a homework assignment. I'll say do like X number of problems. We'll talk about tomorrow. So all right, cool. I think we're all set.
She really don't